Today we're dealing with I wouldn't say old chestnut, but it's come up a lot lately. It's this idea that since since there's undersea cables, there's no such thing as satellites. Well, flat earthers trying to make all kinds of excuses for why there aren't satellites. One of them is they call weather balloons satellites, but we'll let this guy explain his point.
I don't know why I'm just finding out about this, but did you know 99, yes, 99% of our communication and internet is run through underwater sea cables? Also, did you notice that there is no cables that run from South America to Africa and from Africa to Australia? Like if we live on a globe, why aren't there that run from here to here, here to here? I think I know why. Back to the map, so think of Australia as 1, Africa as 2, and South America as 3. So here we have the Gleason's map, and the reason you won't find any cables that run from Australia to South America to Africa is, look how far.
You just don't need it because they're already connected, like through Australia's connected up through Borneo, and Africa and Europe and Asia are all connected. Plus, it probably costs a lot of money to run those cables from like Africa to South America or South Africa to Australia. So they just don't need it. So they didn't build it.
They are. But bro, what about this and this? It makes perfect sense on a flat earth map, here to here and here to here. Over 99% of international data traffic is transmitted through underwater sea cables. But what about satellites? As satellites currently carry just about 1% of global internet traffic, the remaining 99% is carried by undersea cables. Also, this is a little weird.
This pie graph shows the different kinds of satellites. Starlink takes up the most now because they've got over 4,800 when this was done in 2023, I think. But there's other uses for satellites, such as weather satellites, spy satellites, GPS, and all kinds of other uses. The reason why it's not used a lot for communications is because there's a term called latency, which is the delay for the signal due to the signal traveling. For GPS, for the geostationary orbits, which are the highest, which is about 35,000 kilometers, it can add about 4 or 5 milliseconds, which doesn't seem a lot, but because of other factors, that can add up. So if you're doing anything like communicating back and forth or gaming, it can take a while for that signal to go back and forth. Plus, people can actually see satellites naked eye. If you go out in the middle of the night and you see something fast moving and it doesn't have blinking lights or a jet sound after it, it's probably a satellite. Plus, a lot of people nowadays, because of Starlink, get streaky images like this. This is somebody who took a bunch of Starlinks crossing the path. They just left the exposure open and took a lot of these. I've actually seen a trail of a few dozen Starlinks just out in the field outside of my house. One night I went out, looked, and there was about 2 dozen little dots following each other, and these were new Starlinks that haven't been deployed to their orbits. So you can see them plain as night. Okay, let's get back to him.
South America to Africa is, look how far they are. But bro, what about this and this? It makes perfect sense on a flat earth map, here to here and here to here. Over 99% of international data traffic is transmitted through underwater sea cables. But what about satellites? As satellites currently carry just about 1% of global internet traffic, the remaining 99% is carried by undersea cables. Also, this is a little weird. But what do y'all think? Y'all let me know in the comments.
I think you need to do some research and not find somebody who knows the night sky and not go follow a flat earther. But that's the problem, is they watch each other's videos and they think they know everything. But okay, have a good night, and I hope this informed you a little bit, and I hope you can actually hear it. But have a good night, and see you again, or hear from me again. Bye.